To make all of these compositions that we were just talking about a little bit more fun, we're going to mismatch them. So instead of doing stuff like, hey, cosecant together with arc cosecant, what if we did something like cosecant composed with the arctangent of negative 5/12? Let's see what this is equal to. Why are we doing this? It's a secret. I can't tell you just yet. But it'll all come together. It'll all come together. Just trust me. Okay. So what this arctangent is doing, remember that this is a ratio of sides. It does mention the Pythagorean theorem. These are a ratio of sides on a right triangle, right? This is the opposite side, and this is the adjacent side. And the arctangent of this ratio is supposed to spit out an angle. And it looks like this. This is the tangent of some angle, which I don't know, is supposed to be equal to a negative 5/12. Well, this negative is just right up front, but I have to make a decision. Is that negative going to go with the 5 up top, or is it going to go with the 12 on the bottom? Because it makes a difference. The reason why it makes a difference is because in terms of trigonometry and let's say the unit circle, remember that this is supposed to be the y coordinate and this is supposed to be the x coordinate. If this is the y coordinate, this means that it's down 5 and this one means that it's right 12. What quadrant would that be in? Here, let's kind of graph this. It looks sort of like this. I'd go down 5 and I'd go right 12. It would be this kind of triangle right here, okay? There's that theta where this is a negative 5 down and this is a positive 12 across. Okay, so let's try to do it if I do it in the reverse order. So now this time, this means up 5 and then to the left 12. So up 5 to left 12, our right triangle is going to be over here in quadrant 2. So here's our theta of 5 and a negative 12. Which one do I choose? Do I get to use both? No, I do not. I do not get to use this one over here. And the reason why I don't is because in terms of arctangent, which is what we're working with here, arctangent is only defined on the unit circle. Draw a unit circle here. On the same, almost the same exact interval as sine, and that is on the right side of the unit circle. But I do not get the endpoints here. This is negative pi over 2 and positive pi over 2. Okay, this is why this guy right here gets eliminated and we get to keep this one, because this is an angle that arctangent will reveal for us. This is not an angle that arctangent will reveal. So I could never get an obtuse angle from arctangent. Likewise, you can't get an obtuse angle from arcsine. The only one that will give that to you is arccoside because of its interval from 0 to pi. All right, anyway, so here I've just established a right triangle, and I'm just going to continue using the Pythagorean theorem and getting this hypotenuse. I don't even have to use the Pythagorean theorem. I already know it's 13. It's a 5, 12, 13 right triangle. And I don't have to worry about a positive or a negative on that one because it's the length of basically the radius of a circle, right? If I were to draw a circle around that thing. Okay, so now with this angle that I've just established, I want to find now the cosecant of that angle. That cosecant of whatever that angle is. I don't even need to know what that angle is. Whatever, it doesn't even matter. I want the cosecant, which is a ratio of sides. I don't tend to use cosecant. Instead, I think of it as 1 over sine, right? The reciprocal of sine. And sine's really easy to find. Sine of my angle is supposed to be equal to the opposite side over the hypotenuse side. My opposite side is negative 5, and my hypotenuse is 13. And so as cosecant then, I'm just going to reverse the order of this, going to flip those things over, and I get negative 13 over 5. So there's my answer there. Negative 13 over 5. Why? We'll see. All right, let's try another one. Let's do one with some algebra, okay? So this time, our function is going to be this. The tangent of the arc cosine of x over 3. Going to do the same kind of thing that we did before, and that is this establishes an angle. And I'm going to draw a right triangle for that particular angle, and then I'm going to take the tangent after I've completed, let's say, the solving that right triangle with the Pythagorean theorem. Okay, so this part here is going to establish an angle. It means the cosine of some sort of angle is supposed to be equal to x over 3. And notice it's already set up as a ratio for me, where this will be my opposite side and this will be my hypotenuse side. And think about where cosine is supposed to be. Arc cosine, I should say. Arc cosine on the unit circle lives on the top from 0 to pi. It was on the top part. So it's a safe bet to just draw our triangle here in quadrant number 1. So here's our angle. And let's label our little pieces. The adjacent side, I may have misspoke. I may have said that was opposite before. I don't know. Rewind the video. You can tell me later. The adjacent side is x and my hypotenuse side is 3. Let's continue to solve that. We'll have to use the Pythagorean theorem on this, and it would be an x squared plus, I don't even know what that squared is. I don't know. I'll call it a b. B squared is equal to a 3 squared. And I'm going to solve this thing for b. So let's just kind of do it in our head. That 3 squared would be a 9. I would subtract over the x squared, and then I'd have to take the square root. So it's the square root of 9 minus x squared. That's what goes right here. Okay, there we go. And now I want the tangent of that angle. So the tangent of that angle is now the opposite side, which is the square root of 9 minus x squared over my adjacent side, which is x. All right, so we just basically turned this trig expression into an algebraic one. Now here, let me just kind of highlight a couple of things again. Whenever I'm taking the arc sine, the arc cosine, or arc tangent of something, I'm getting an angle. This establishes some angle. And notice at no point did I actually ever solve for that angle. I used it to generate myself a right triangle, and then the tangent just wants a ratio of the sides in that right triangle, specifically the opposite over the adjacent side. Okay, now it's your turn. Your turn. I've got 2 of them for you. So take yourself a screenshot or something, or pause the video. Right here at the end, I want you to evaluate each of the following. First one is the cosine of the arc sine of x. Let's see what you get. And then on the second one here, a numerical one, what is the tangent of the arc secant of the square root of 5 over 2?